Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Imagine this, you build a state of the art image model. It can draw stunning cats, futuristic cities, surreal art, beautiful. But then you give it a simple twist. On this planet, gravity depends on color. Suddenly, it collapses. This is the core story behind the paper, Genius Generative Fluid Intelligence Evaluation Suite by Ruichuan and Sihan Yang, along with their collaborators. And today, we're diving into why this benchmark changes how we measure intelligence in generative models. The authors ask a bold question. Are today's multimodal models actually intelligent or just really good at memorizing? They borrow from classical psychology, fluid intelligence versus crystallized intelligence. Most benchmarks test crystallized intelligence. Can the model recall what a cat looks like? Can it render a known concept beautifully? But Genius focuses on generative fluid intelligence or GFI. That means, can the model infer hidden patterns? Can it follow completely new ad hoc rules? Can it override its own pre trained knowledge when the context demands it? In other words, can it think on the fly? Genius breaks this into three core dimensions: implicit pattern induction, inferring unstated visual preferences; ad hoc constraint execution, reasoning under brand new symbolic or visual rules; contextual knowledge adaptation, adapting even when rules contradict real world knowledge. The benchmark includes 510 manually curated samples. Each sample is multimodal and interleaved. Remove one modality, and the task becomes unsolvable. Evaluation uses three metrics: rule compliance, visual consistency, aesthetic quality, and interestingly, they use Gemini 3 Pro as an automated judge, validated against human raters. Now, here's where things get dramatic. They evaluate 12 models, open source and proprietary. Even top tier models like Nano Banana Pro fail to reach a passing grade. Open source models like Bagel perform far worse. But the most fascinating insight, models score high on aesthetic quality, yet low on rule compliance. It's an illusion of competence. They generate beautiful images that logically break the instructions. So, what's going wrong? The authors run diagnostic experiments. They convert generation tasks into VQA style multiple choice questions, and they discover something surprising. Models often understand the rule, but fail to execute it during generation. They call this the execution gap, a know but cannot draw phenomenon. This suggests the bottleneck isn't always comprehension, it's translating that understanding into control generation. Then comes the deep dive. They visualize attention maps inside the Bagel model. What they find is chaotic. Attention spreads across irrelevant tokens, noise spikes everywhere, critical rules aren't sharply focused. The hypothesis: in context learning behaves like implicit gradient descent. If attention is noisy, the implicit gradient direction becomes noisy. So the model defaults to its pre trained priors. Their solution? A training free attention adjustment mechanism, three steps: keyword distillation, relevance mapping, bias injection into attention logits. Mathematically, they suppress noise tokens and amplify critical signals. And it works. Bagel's score improves by over 6% without retraining. Genius sends a clear message. We have optimized for beautiful pixels, but not for true reasoning. If we want general intelligence in generative models, we need to move beyond memory and toward fluid adaptability. And that's the real genius behind Genius. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.